Here's your recap for U-shaped tubes. We'll start with how to do it. You need two diagrams usually. You need one diagram before any change, so when there's a single liquid in the U-shaped tube, and a second diagram, which is the one on the far right, after a second or a third liquid has been added. Now you'll note there that we have a reference line, which is a dotted or the dashed horizontal line. The reference line there for this particular diagram is the reference on the left. And the reference line is always the highest point that you can go to whereby the liquid in both columns is the same. So the left-hand diagram, the highest point that you can go to in both columns where the liquid is the same is denoted by the dashed line. Now that reference line is not right then for the diagram on the right. So let's put in the line there. There we go. So the red line there is the reference line for the diagram on the right. And what we know then is each column, if one is A and the other one is B, then the pressure in column A on the left should equal the pressure at column B on the right at the reference line. So A and B at the reference line, pressure is equal on both sides. And then we just use P is equal to rho GH on both sides, typically to solve for an unknown value. So let's have a look at some questions. 2004, we have a U-tube whose limbs are vertical. It contains water. Then we have liquid A of relative density 0.95. So the actual density is 950. Density of water is 1000. You're supposed to know that. Is poured into the left limb. And then liquid B is poured into the right limb and its density is 925. Now the two levels are then equal. The height of the column on the left is 12 centimeters. Find the height of the column of liquid B. So we need to put in our reference line. First of all, we go as high up as possible so that the liquid in both columns is still the same at the reference point. So it's that high. Now we have column A and B. The pressure at A should equal the pressure at B. And you'll notice there that I've labelled the height of B as X because that's what we're looking for. So pressure in A equals pressure at B at the reference line. On the left we have one liquid. On the right we have two liquids. So I'll have rho GH for the left is equal to the sum of two rho GHs on the right hand side. Subscripts A and B are for liquids A and B, and subscript W is for the water. And you just fill in your values. So you'll notice there that I fill in the density, not the relative density. So 950 by 0.12. Again, SI units there. And the G's cancel across all the terms. And that's going to equal 925 by the height X for liquid B. And then if the whole thing is 12 centimeters and B is height X, the height of the water is 12 centimeters minus X, which is 0.12 minus X. You could just solve for X then in that case. Second question, 2011. So we read through it. A U-tube of cross-sectional area 0.15 contains oil of relative density 0.8. The surface of the oil is 12 centimeters from the top of both branches of the U-tube. So my diagram there shows the reference level whereby the liquid in both tubes is the same at the highest point. We're then told what volume of water can be poured into one of the branches before the oil overflows in the other branch. So I'm going to pour water into the left-hand side, and because water is denser than oil, less water will cause a greater rise in height for the oil. So the water will go in the left, it'll push down the oil on the left and push up the oil on the right. And the thing to remember here is for one side to overflow, the right-hand side is what I'm going to look at. It's going to rise by 12 centimeters. But the other side, it needs to drop by 12 centimeters as well. So it looks like this. Right, so we push down with the water on one side, and then the oil rises by 12 centimeters on the other. And what happens then is if one side drops by 12 and the other one rises by 12, the height above the reference line, which is that in this case, is now 24 centimeters. So the height of the oil on one side is 24 centimeters. Okay, I'm going to redraw the diagram. So it looks like that. So we have oil on one side on the right, water on the left. And now your reference line will be the highest point that you can go to, whereby there's liquid of the same type in both columns. And then we just use pressure at A equals pressure at B. We have rho GH on the left equals rho GH on the right. The G's cancel, and you solve for the H value on the left. You should be able to do that. Okay, I put a pause here, and I'll finish the other questions in a moment in the second video.